few absolute legends. The sulfite anion, a great Lewis dot structure for a Gen Chem student, would require these three criteria in here, in this order, I would say. The total electron count for the sulfite anion, each atom has an octet, and the formal charge of each element is close to 0. This picture on the left side here is a great Lewis dot structure. It hits a lot of these points here. It's got 26 electrons. That's all it's allowed to have. Each element has an octet. Let's calculate the formal charge for each of these elements here. So sulfur, let's start in the center right here and work ourselves out. Sulfur has 6 valence electrons in its neutral state right here. It has 2 electrons in lone pairs and six electrons in bonds. Divide that by 2, it's 3. We have 6 minus 2 minus 3. This sulfur here has a +1 formal charge of that element. Let's do this oxygen out here. Oxygen, looking at the periodic table, has 6 valence electrons in its neutral state. We subtract all of the electrons in lone pairs, that's 6. And then we take the number of electrons in bonds and divide it by 2, that's 2. Divided by 2 is 1. So 6 minus 1 is -1. So this oxygen has a -1. And each of these, all of these oxygens are what we call isoelectric, meaning they are in identical electric situations. They have 1 bond and 3 lone pairs. So we have our formal charges here, and then our formal charges add up to -2, which is a great double check because overall this molecule has a -2 charge here. Now for a Gen Chem student, this is a great Lewis dot structure because it fits the criteria. Total electron count's 26. Every element has an octet. The formal charges. Now, none of these have a formal charge of 0, but we can say that the more electronegative atoms have a negative charge, and the more electropositive atom has a plus charge here. Now let's consider this Lewis dot structure that you'll find. And let's discuss why this is also a good Lewis dot structure. Now, I want to be clear that what we're doing with this Lewis dot structure is adding more rules or more special situations to the chemistry arsenal that's ever growing. This Lewis dot structure here has 26 electrons. Now, each element has its quote-unquote octet. Now, I say quote-unquote this because let's look at this sulfur in the middle here. This sulfur has 10 electrons as part of its quote-unquote octet. Now, octets for elements in Gen Chem. Hydrogen and helium are happy with dose electrons. That is their octet. And because they're so small, their valence shell of electrons can hold dose electrons. Think of the opposite situation. When an atom is bigger and bigger and bigger and bigger, they can accept more and more electrons. Sulfur is becoming large enough of an atom that it can handle 10 electrons in its valence shell here. So this octet of sulfur is one of those special circumstances to put in your arsenal here. Now there is a trade-off with this. If we're going to accept this 10 electrons in the valence shell, we better get a closer to 0 formal charge calculation for individual atoms. Let's do the formal charges here for this sulfite anion Lewis dot structure. These 2 oxygens here are both single bonded and have 3 lone pairs. Isoelectric to these over here. So they're going to have a -1 formal charge. This oxygen element here, let's do the formal charge for this one here. We have 6 valence electrons. Oxygen always starts with 6 in its valence shell. -4 electrons from the lone pairs. And then there's 4 electrons in bonds divided by 2, 4 divided by 2 is 2. So 6 minus 4 minus 2 is 0. Sulfur here has 6 valence electrons by finding its location on the periodic table. It has 2 electrons in lone pairs and 4 bonds, 8 electrons in bonds. So 8 divided by 2 is 4. So we have 6 from the periodic table, minus 2, minus 4 is 0 here. When we add up the formal charges of each of the elements, we get an overall charge of -2. That's great because that is the overall charge of the anion here. So this Lewis dot structure has a little bit of a trade-off, and this is the cause of a lot of confusion here for Gen Chem students. You know, why is this a good, if not better, Lewis dot structure? Now, because of the balance or trade-off between these two criteria right here, the octets and the formal charge. When you have drawn, when we take a prediction that sulfur has 10 electrons in its valence set, we have gotten closer to 0 formal charges. Our electronegative atoms are carrying a negative charge here. So it is this balance of play here that you gain through experience and understanding some of the exceptions to the rules when it comes to learning chemistry. I hope this helps. Please comment if you have any other questions. Thank you.